In this video, we're going to take a look at graphing a parametric equation with the calculator. So it tells us to consider that x equals t squared plus 2t and y equals t plus 1. We're going to use a graphing calculator to find the points that are determined by t when it's negative 3 to positive 3. So in order to do that, what we first have to do is we have to set our calculator to take that equation. So we have to set up parametrics. So in order to set up parametrics, we're going to turn on our calculator, go to mode, and if you take a look here, we're on function, we move over 1 and hit enter for parametrics. Okay, so to set up the parametric equations, we did mode and then we did parametrics. Okay, with that, we're now going to go into y equals. What that allows us to do is put in an equation for x and an equation for y. Exactly what we have here. So as I do that, I have to do t squared plus 2t. T is on the x key, so we have t squared plus 2t. Then our y equation is t plus 1. Okay, so we're able to get those in there. What we can do from there now is to look at the table. Okay, because we want to find what the points are. So to get our table is second graph, and you can see that the table generates the t column, the x column, and the y column. We wanted the table from negative 3 forward, so I need to scroll back here from negative 3. So using graphing calculator to determine the points for negative 3 to 3. So what I find is that negative 3, my point is 3, negative 2. At negative 2, negative 1, 0, 1, 2, and 3, I can pull off all my points. 0, negative 1, then I have negative 1, 0. At 0, I have 0, 1. Then at 1, I have 3, 2. At 2, I have 8, 3. And finally at 3, I have 15, 4. Okay, so I was able to go to y equals, then I was able to do second graph to get to my table. Okay, from there, we have to find an algebraic relationship between x and y. The only way we can do that is by hand, just like we had done before. Okay, so we are going to take a look at our equations. X equals t squared plus 2t and y equals t plus 1. So just as we did before, this equation we're going to solve y minus 1 equals t, and then we're going to use the process of substitution to come up with our equation. So we're going to sub that in. We'll have y minus 1 quantity squared plus 2t equals x. Foiling that out, it's y minus 1 times y minus 1. I have y squared minus 2y plus 1 plus, and right here, instead of t, I have to sub in y minus 1 again. So 2y minus 2 equals x. Okay, so to finish this, then, I have, collecting like terms, y squared minus 2y plus 2y cancels, minus 1 equals x. Okay, so I have created an equation from the two parametrics that I was given up here. Okay, then use the calculator to graph this in the xy plane. So we have to graph that. Notice our calculator will not accept that equation because that equation is an x equals equation. So we have to graph it from our parametrics up here. So if we go back into y equals, here are the two equations. Okay, we need to set up a window that's going to work for us. So when we set up the window, we have a t min and a t max, we have a t step. We have an x min and an x max, an x scale being 1, a counter, and then we have a y min and a y max. Okay, so as we look at this, okay, looking at our y is t plus 1. So we're probably going to want our y's to run from -3 to 3, okay, so that we're in the ballpark. Our x values, we're going to want to run from one different than that, so we'll run -4 to 2. Okay, and our counter is going to be by a 0.1. That just controls how smooth the curve is. Okay, so again, the T-min is -4, the T-max is 2. That comes from these numbers with this 1 on it. My T-step is going to be 0.1, it gives me a smooth curve. My X-min and max is just -5 to 5. We could start -10 to 10, but I know I'm going to want to be zoomed in. My scale is 1, and then my Y-min and max is just -3 to 3. So now we're able to hit graph. What you see is that I get a sideways parabola, and hopefully that makes sense to you, because if the X and Y were switched here, I would have a parabola that opens up and down. And now that these are switched, my parabola is going to open sideways. Okay, so use the calculator to graph in the XY plane. So what I want to record here is what I did for my window. Okay, in the window we had a T-min and we used -4. We had a T-max and we used 2, and we had a T-step and we used 0.1. Okay. Then we had an X-min, and that was -5. We had an X-max, and that was +5. We had a Y-min of -3 and a Y-max of +3. Okay, so is y a function of x? Is this the graph of a function? No, it's definitely not, because it does not pass the vertical line test. So you won't be asked often to solve on the calculator with the parametrics. It tends to get a little confusing, but you will definitely be asked to convert to an algebraic relationship, and to actually be able to solve these by hand as we did on the previous video. But if you know how to get this into your calculator, at least that's a good quick check for you.